In this recording, we're going to continue to learn how to solve systems using the graphing calculator. Again, it's a really versatile technique. So the first problem we have here is to solve this linear equation. It says solve it using standard, meaning algebraic methods, and then show it checks. So pause and go ahead and work this out. Play the recording when you're ready. Hopefully you took time to do that. If you didn't, please do it now. Basically, I just want to get x by itself, right? So I'm going to add x to both sides. Okay, so at this point it says show it's a solution by checking. Let's just do our little check up here. So if x is 3, we got 3 times 3 minus 2 equals 10 minus 3, right? So in our head, 9 minus 2, 7, equals 10 minus 3, 7. Yep, checks out. Okay, so now that we have in our head what the solution is, we're going to show how we could have solved this using a graphing calculator. Basically, we're going to turn both sides of the equation into their own y equals. Okay, so we're going to basically put into y1 and y2, and we're going to look at the table to get these values. Okay, so in our graphing calculator, we're going to enter 3x minus 2 in our y1, 10 minus x in our y2. Okay, so I'm sort of representing the left and right hand side of the equation. Now I'm going to look at my table, and I'm specifically interested, I need to move up a little bit because I'm specifically interested in 0 through 4. Okay, so for each of those x values, here are our y values. And now we can put those values into our table. So for y1, when x is 0, y is negative 2. Now that's no surprise, right? If I had algebraically substituted 0 for x, 3 times 0, and then minus 2 would be that, right? And then I can see the slope. The slope is going up by 3 each time, right? So each of these should go up by 3. So it's no surprise that it's 1, 4, 7, 10. It's going up by 3 because the slope is 3. All right, let's see what's happening with the y2. The y2, if I were to sub in 0, it would be 10 minus 0. That would be 10, right? Sure enough, that it shows that. At 0, the y2 is 10. And the slope is the number in front of x, so it's like a negative 1. So these are going down by 1 each time. All right, and that all checks out with the table. All right, so I'm going to delete that right there. So then it says, okay, go ahead and make a graph of this on your graphing calculator using a window of x between negative 2 and 6, y between negative 2 and 11. Well, that's good because we've already got it into our y equals. We just need to set up our window. So it said x between negative 2 and 6, y between negative 2 and 11. Keep in mind you're using the negative button for your 2's, not the gray subtraction key. Now you can just hit graph. Okay. It says make a sketch of this. So y-intercept at negative 2. Again, we should label up our axes. Negative 2 up to 11 in the y direction, and the x negative 2 to 6. All right. I was remiss in the last video. I did not have us label the equations, and we should always do this. Okay? Anytime we have more than one axis, anytime we have more than one function on the same axis, we must label. All right, so that approximates the graph, and I should label. So this is the first one with a y-intercept of -2. That would be y equals 3x minus 2. And then this with the y-intercept of 10 would be y equals 10 minus x. At this point, I'm done with that. Get rid of that. Now to find the intersection point. Well, did you see the intersection point? Let's go back to your table that you generated up here. Circle it. Do you see the intersection point at all? The point in your table where the y values were the same? Of course you did, right here. 7 and 7, right? So that seems somewhat reasonable, I guess. You know, when x is about 3, y would be about 7. That seems reasonable. I want you to use the technique that I just taught you in the previous video, to use your calculator, go to Second Calc, and go through the process to find the intersection point. Play the recording when you've got it. Okay, so 5, first curve, enter, second curve, enter, guess, just move close. 3, 7, we thought it would be, right? We had predicted that much from our table. All right, so then to summarize, to solve the equation where one function equals another function, okay, you graph both f of x and g of x and find the intersection point or points of their graph. All right, so let's end by looking at a nonlinear system, a nonlinear equation, where we have a quadratic on one side and a linear on another side. Of course, we could solve this quadratic, right? It has a square, so it's called a quadratic. But we're going to solve it graphically. We're going to look to where this y1 side and this y2 side intersect each other. So go ahead and put those into your graphing calculator. This side into y1, this side in y2. Play the recording when you're ready. Okay, it does give me some suggestions for the window. The x is between -8 and 8. The y is between -20 and 20. If it had not given me the instruction, I would have had to look at my table to get a clue for where the intersection was and maybe do a little trial and error. There's nothing wrong with that either. Okay, there's our parabola. And there's our line. Okay, so we're going to label our axes. We went from -20 to 20 in the y, excuse me. In the x, -8 to 8. That's what this told us to do, right? Those intervals, the domain and the range, if you like. I'm going to add those words in. Those are good words to keep in our forefront. The domain and the range of the window, right? So let's just make our sketch here. Y-intercept of the parabola we know is -11, right? Because that's the c value of the parabola. So I'm going to go about halfway and just a little more. Okay, I think I like one side of this parabola a little better. I'm going to try one more time to make it good. A little better. Then your line tool, you've got a y-intercept of 4, slope of -2. So it looks something like that. All right, now we just need to label. Okay, so we've got this nice graphing setup. We just need to get our answers here. So I'll leave it to you to use the tool here, the intersect tool, to try to find this intersection point right there. Play the recording when you're ready. Okay, so you did second calc, intersect, first curve, yes, second curve, hit enter, guess. Well, this is where I need to have my guess a little bit closer to the left. It's got to be close to that point. And it turns out the intersection is at -5, 14. And now repeat the process, but this time when you do guess, make your guess be closer to this intersection point, which is a positive x value. So hopefully you did it on your own. Pause, play the recording when you're ready. Okay, and the other intersection point is at 3, -2. All right, and I leave it to you to do the checks by substituting back in the x values, -5, make sure that -5 checks, and then substitute in the 3. Substitute in 3 to both sides and make sure it checks. So check x equals -5, and then check x equals 3. Noticing that we're not actually using the y value at all to check. Thanks for watching.